In this video, I will show how to find the determinant of a matrix. The first method is to find the determinant directly by multiplication, and the second is by using something known as converting the matrix to a triangular matrix. So randomly I will take a matrix given by B is equal to 1 2 0 and 3 6 0 and 1 2 2. So this is a matrix, and if I want to find the determinants, then this is C1, C2, C3 are the columns, and the R1, R2 and R3 are the rows. So I can consider this first by taking C1, and then what I want to do is I want to cross multiply this in such a way that I can write it as 6 0 and 2 2. Then I will have to take a minus of what comes for my C or C11 and C21, and when I am taking a C21 this variable here, then I will have to consider for these two rows for multiplication. So when I am taking that, it will become 2 0 and 2 2, and then it is a C3 1, and this is 2 0 will come here, so I will consider these two, and 6 0. So putting in this is what is my determinant of the matrix, and determinant of the matrix is, so my C11 is 1, and when I am cross multiplying I will have to multiply this. This is my A and this is my B and this is my C and this is D. Then I will multiply AD first in such a way that 6 into 2, and this will come minus, so minus of 0 into 2, and then minus of C21 which is 3, and again doing the same way, it is 2 2s are 4, 4 minus 0, and again doing C31 which is plus 1, and this both are 0 minus 0, so it will become what is 12 minus of 12. So my determinant is 0 in this case. So suppose I am taking a matrix with a 1 here. So what will happen is there will be change a 3 cross 3 matrix. So if my matrix is given by 1 8 2 and 4 1 8 0 2 0, then the determinant can be simply found out by in such a way that if this is my C1, C2 and C3, then and this is my row 1, row 2 and row 3, then C1 1 into what is the adjacent there, so 1 8 2 0 minus C2 2 1 into 8 2 2 0 and minus or plus C3 1 into what is 8 2 1 8. So this becomes, what is my C11 is 1, C21 is 4, and C31 is 0. So this is 1 of 0 minus 16 minus of 4 into 0 minus 4 and plus of 0 into 64 minus 2. So this is minus 16 plus 16, which is equal to 0. So I have solved some matrix. So again, the matrix which was solved earlier also had a solution which came to be 0. So randomly taking matrix which is giving 0 solutions. So again, trying one more matrix. Two, 8, 8, 1 and 1, 1 and 1, 2 and 3 or 4. So again, this matrix, doing it the same way. So 2 into multiplying this 4 minus 2 minus of 1 into this and this. So 8 fours are 32 minus of 16 and plus 1 of 8 minus 8. So this is 2 into 2 minus of 1 into 16. So 4 minus 16, which is equal to 12 or minus 12, which gives a more determinant of 12, could be my answer. So again, if I'm trying to convert this matrix to a triangular matrix, then 2, 1, 1 and 8, 1, 2 and 8, 1, 4. So my idea is, the first step is to do a R2 3 minus 1. So that will give me 2, 1, 1, and when this is by using the triangular matrix method. So I will convert this matrix to a triangular matrix, and 8, 1, 2 and 0, 0, 2. Now the next task is to make this 0. So the next step, so to do that, is to multiply R12 by minus 4, and already I have divided by minus 4 here. So this is equal to minus 1 by 4, 2, 1, 1 and 0. And minus 3 here. And minus 2 here. And again this is 0, 0, 2. So this has become my triangular matrix, and the determinant is equal to the product of what is there in the diagonal. So it is equal to modulus of minus 1 by 4 into 2 into minus 3 into 2. So again, there is no need to do a minus 1 by 4 here to give it. So it is simply the diagonal, and so the answer is 4 3s are 12. So this is how I can find the determinant of a matrix by multiplication, and also by using what is known as by converting the matrix into triangular matrix. So again, when I have matrix like a 3 cross 3 matrix, it is very simple to convert it into direct multiplication by taking one coefficient and having the values from the other two columns to multiply. But when there is a larger matrix like a 4 cross 4 matrix, then by converting the matrix to a triangular matrix, the determinant can be directly found by taking the product of whatever values is left in the diagonal.